So let's say they ask, they tell you ammonium nitrate with potassium hydroxide. Okay. And then B, okay, I lazy to write, ammonium nitrate and potassium phosphate. Okay. And C, ammonium phosphate and potassium hydroxide. Okay. And then D, uh, potassium sulfate plus zinc nitrate. Let's say like random lah. Okay, so they ask you which combination is the best. Why cannot C? You see, A got ammonium nitrate. So your nitrogen, potassium K, correct? 这个 B 也是有 potassium and phosphate, correct? Correct. But why not C? C 是 ammonium phosphate potassium hydroxide. Correct. Your answer is B, but why not C? No, this one also 两个，这个三个吗？这个三个吗？ammonium phosphate 这个有 phosphorus 吗？potassium alkali, alkali not acidic. Because this one is alkali, cannot. When we do fertilizer, it must be neutral. Okay, basic, very simple one. So this NPK fertilizer is not complicated. They won't ask you like, oh, how do you make NPK fertilizer? No, it's just asking you which one is the fertilizer. Like that. Very simple question. Get it? Okay. And then what else I got you? Actually, this whole chapter finished already, right? 这个 chapter 很短罢了嘛。呀啦。Okay. So I was telling you guys, right? Okay. We have done 1, 2, 3, 4, 5, 6, 7. Finish already. Okay. And then this one, the testing also we did already, right? Right? And then now we finish this. So we have only 1, 2, 3 chapters. We can actually finish very, very fast. If you guys want to have like extra class during holiday, okay, then Jet, then we can finish faster. Do you all remember I printed for you? Yes.
Yeah, I still have it.
He said he still have it. You have it. Okay. So we talked about all of this already. Okay, we talked about all of this. We talked about water. Okay, we talked about the dissolved salts. We talked about fertilizer quality. Did we talk about it? Yes, right. Polluting, carbon monoxide. Okay, carbon monoxide. If they ever ask you what's wrong with carbon monoxide, it's toxic. Dioxide is global warming. Okay, can? And then we went through catalytic converter, right? The one about the car. Yes, right. Okay. All right. Okay. Now, so today, Kathleen, are you okay? I've never seen you so tired. Do you want to drink some water? Are you hungry or what? Sleepy. Okay. All right. So now we're going to do uh this chapter called periodic table. Okay. Now, everybody knows how the periodic table looks like. If you don't know, we will all sit down and cry, okay? So, where's the periodic table? Where's my periodic table? 怎么找不到？ there. Okay, wait, I just want to make a copy. Okay, so few things you need to know. Number one, they will give you the periodic table in exam. You no need to go and memorize. Hey guys, my 6.5-year-old that boy the one that went for exam, now he's 7 already. When he went for his IG exam, he got 88 You all must get more than 88, okay? What? Wow. My 6.5-old, what do they call it? 天才 He got nothing to do He go and sit for exam. Wow. So nice. Okay. So please get higher than 88 He's homeschool Because he's genius, he go to standard 1, 2 some more. Now I'm teaching him bio. Not my kid. He's later I share with you. I share with you guys in the group. Okay. Wait I share with you all later. Wait Yeah. There. Okay, later I share. I put in the group. Later you all see. Yeah, he's there. This is my online student. He got 88 for Chem, IG Chem. All of you must minimal get 98. All of you must be game, okay?
Minimal 98.
Minimal 98 lah. Get higher than him, okay?
Isn't the max score 100?
Yeah, max 400. So minimum 98, okay? My highest student ever got is 97. I still haven't got a student got 98. Y'all get 98 for me, okay? Come on lah. 忘记了
What?
My highest student is 97. Reina Shah. She got 97. Ray 100啦 My 100 I got student got 100 for Bahasa, for Malay, not my student lah. For math. No, I didn't teach math lah, but he got 100 for math. Okay. Focus, let's focus. Okay, so in this chapter, the periodic table of elements is very easy. You just need to know group 1, group 8, group 7, and then transition elements. That's all. Okay? Group 1, group 1. Don't need to draw this, you just draw on your periodic table lah. Group 1 is in the syllabus content. 没有 meh? 最后一面没有OK 啦 never mind 啦。我 print 很多张给你了。Alright. So group 1, group 7, group 8. Okay? So this is transition metal, you know, right?
Yeah.
Okay? So titanium, chromium, cobalt, nickel, copper, zinc, these are all the common ones you've seen. Okay? Can now lead here and tin here, they act like transition metals. So okay. Alright? Yeah, because remember we have that line. Semi-metal. No, they are considered group 4, but they act like transition metal. But don't worry. They very rarely ask you these two. They will ask you the most common one. The most common one they always ask is who? Copper. Everything also copper. Because copper got many colors. Alright? Now, group 1 is called colloid metals. Why is group 1 called alkali metals? Because group 1 dissolve in water to form alkali. Good. All right. And then group 7 is called halogen. And group 8 is called noble gas. And then the middle is called transition metal or transition elements. Sorry, what? Which one? Which one? Noble gas 啊，哎呦，那个我不会了。Sorry. Noble gas is basically group 8. They don't do anything. They are very chill because they have a full outer shell. Okay, they got full outer shell, so they don't do anything. Huh? Group 1 is alkali metal. So you only need to remember these special names. Group 1 is alkali metal. Group 7 is halogen. And group 8 is noble gas. And the middle is called transition metal. Special name lah, the special name. The group 4 is group 4 lah. Halogen is group 7. It means to form salt because they are used to form salt. Yes, this one because it has a full outer shell. So remember, group 8 has a full outer shell. Okay, full outer shell. Why? Oh, no more exams. Okay, can? All right, I'm sure you know group 1, everybody got one valence electron. Group 2, everybody 2. Group 3, everybody 3. You know that, right? So if I write, for example, an element is 2, 4, straight away you know it's in group 4 and it's in period 2 because got 2 shells, right? You know that, right? Remember or not? So if I write something is 2, 8, 7 is group 7, and then period 3 because got 3 shells. Remember or not? Yes, this one doesn't change, okay? So what you need to learn is, okay, now in the periodic table here, okay, what you learn in this chapter, it's not a lot. Don't worry, guys, it's not a lot. It's a very short chapter. The key things that you learn is, where did it go? Okay, you see the chapter is this short. I show you how short it is. This one, this one, and this one, and that's it. Finish it. It's only 2 pages. It's only 2 pages. And I've already taught you page 1. I already taught you the first half already. Arrangement, the one that is, if it's 281, that means it's in 1. I mean, it's very easy to do. It's a very short chapter. It's not very difficult, not very complicated. Okay, so now we're going to focus on group 1 properties. Okay, so who is in group 1? Lithium, lithium. So you must remember lah. Lithium, sodium, potassium. Usually the only the first 3 lah. Okay. All right. So, but in exam you'll be given the periodic table lah. So you 你不记得也不用记得 lithium, sodium, potassium. Okay, so of course below that got some more lah. You just have to look at the periodic table. You don't need to memorize. Cesium, francium. Okay. As you go down the group, it becomes more reactive. Okay, more reactive. All right. And then the So the reactivity increase, the density increase, and the melting point decrease. It becomes easier and easier to melt.
Sure, I know it won't be
What's that? What's that?
like 100 maybe I know. Even I'm looking for the so
Actually, no, it's because of the arrangement of the electrons.
oh,
Okay, now you see, potassium is, okay, this part that I'm going to teach you, you learn in your Form 4, but you don't learn in IG. Okay, you learn your SPM, but it's still something important that you should know lah. So why is it, you understand this, then you know why is it more reactive. Lithium is 2,1, potassium is 281, sodium is 2,881. So you know, right? Okay, so if I draw a simple atom, right, the middle is positive, right? The nucleus, right? So 2, 1, and then 2, 8, 1, and then 2, 8, 8, 1. As you go down, it becomes bigger and bigger. In order for it to react, what happens is the outer shell, the valence electron, must receive or release. Which one? Release. So this one, the electron is being held by the positive nucleus. 哪一个比较容易飞出去? Which one is easier to release? The one, the biggest one lah. So the bigger it is, the easier to escape. That's why more reactive. 因为它越来越大力. Is it? Yeah, the attractive forces is weaker, lor, basically. Okay, the attractive forces is weaker, so it's easier and easier to release. Make sense?
okay.
Understand, Okay. So now, what does this, I guess then, what does this group 1 do? So it's like this. Lithium dissolve in water, it forms lithium hydroxide and it releases hydrogen gas. Okay? Lithium hydroxide is an alkali. So they dissolve in water to form an alkali. That's why it's called a alkali metal lah. Get it? Now, can you do me a favor and write down the equation for sodium and potassium in water? Huh? But write down the chemical equation for potassium and sodium in water.
Okay.
Okay. Okay. So this is lithium hydroxide, sodium hydroxide, potassium hydroxide. So they are all soluble in water to form alkali. So when you first take the lithium, sodium, potassium, is it solid or a liquid? Of course, it's a solid. It's a metal. Okay, now remember, it is still a metal. A metal is shiny. A metal can conduct electricity. A metal is can conduct heat. A metal is sonorous. A metal is malleable. All of that still applies, but these metals are special. They're soft. They feel like butter. Okay? Water is a liquid. This one is an aqueous solution, and this is gas. Okay? So what do you think you will see if I take a piece of lithium, this water, right? I take a piece of lithium and I put on top of it. What do you think you will see?
Yes.
Lithium
Gas.
glowing.
No, it will start to bubble. It was okay, so it will dissolve.
Wow.
The lithium will dissolve. Okay. Then there's bubbling because for hydrogen gas, right? Now, and it will float and then it will move around. Okay. Now, if lithium moves around, sodium moves faster or slower.
Faster.
And then potassium,
Yes.
even faster, and it will form a small explosion, which is, I'm going to show you a video, okay? Okay, so we need to know the difference between group 1 and transition metal. Okay? So, group 1 will be very, very vigorous. Transition metal will not be so vigorous. Okay, so first of all, let's look at the elements in transition metal, those that you know. So I'm sure you know a lot of them lah. Okay, so transition metal, who do you know? Chromium, manganese, iron, cobalt, nickel, copper, zinc, titanium. You know all these guys, right? Silver, platinum. Let's go lah. Gold, mercury. Okay, so all of these are transition metals. Yeah, everybody here. Alright. Now, first of all, let's talk about how all metals are the same. So group 1 versus transition elements or transition metals. Okay? First, we talk about how they are the same. They are all metals, so they can all conduct electricity and heat. Conduct electricity and heat is 1 mark. When you cut them, they are all shiny.
Facing are very expensive.
No. Okay? They are all ductile, malleable, and sonorous, technically lah. Sonorous means when you bang it, sound like a bell.
Bang.
Mm. Bang. Dang, can be drawn into a wire. Malleable means when you knock it, it will change shape. Can make into a wire is ductile.
Wire.
一条铁线。Okay, kan?
Teacher, that is a shining when freshly cut or
Yeah.
shing.
Shiny when freshly cut. Sorry.
Oh.
Shiny when freshly cut. Shing, sorry. Okay, can? Okay, now all of this All of this, they are called physical properties or chemical properties. Physical. Do you think they share the same chemical properties? Yeah. Metals form positive or negative ions? Positive. So they all form positive ions. And one more thing is, are they basic oxides or acidic oxides? Basic oxides. Metal oxides are basic oxides. Remember not? Calcium oxide, zinc oxide, calcium oxide, copper oxide, sodium oxide. They are all basic oxide. Remember this? Similarities, they're the same. The only thing is these are all called chemical properties. So this is the one on top is physical properties. This one is chemical properties.
Okay.
Okay, now we talk about how they're different. Okay, so example, sodium versus iron lah. Okay? Who is harder? Iron is harder, higher melting point, higher density, right or not?
Yeah.
So it's all terbalik lah. Softer, lower melting point, lower density. Correct.
So transition method shows also harder than
Harder, yes. We talk about typical lah, typical. Transition metal is harder, higher melting point, higher density. Okay? These are physical or chemical properties?
physical.
Physical. Wait, let me see something. Okay. Now, do you remember what is a catalyst?
Yeah.
Who can be used as a catalyst?
Calcium.
Huh?
Never.
No.
Yeah, that's sweet.
Yes. Okay, so this transition metal can be used as a catalyst. For example, iron is used in Haber process. Vanadium 5 oxide is used in contact process. Remember? Okay, so the transition metal, all the transition metal compounds are used as catalyst. This one is not used as a catalyst. Who is more reactive? Group 1 is more reactive, yeah, because group 1 put in water, it will bubble. Okay, group 1, all will form positive 1 only. So the oxidation state is just positive 1. But iron can be iron 2 or iron 3. Correct or not? It can be positive 2 or positive 3. So it has various oxidation states. Now, sodium chloride, what color? White. Potassium sulfate, what color? White. All of them form white compounds. Not very colorful. But transition metal form colored compounds. Iron 2 is green, iron 3 is brown, copper 2 is blue. Remember that?
the uh, one has a single oxidation state.
Yeah. Actually, you just need to remember one of it. Just remember all this part. Transition metal can be used as catalyst. Transition metal has various oxidation state. Transition metal can form colored compounds. This is the most important one. This question, they ask very, very often.
Okay.
Right? Okay. So we did group 1. We did transition metal. Now we're going to do group 7. Okay. Group 7 is halogen. So you only need to know fluorine, chlorine, bromine, iodine. Of course, down there got some more lah. Okay. Now group 1 go down more reactive, right? Group 7 go down is less reactive. But it's also density increase. So density, right? For group 1 and group 7 same. Go down, density increase. Okay? Okay, now I'm going to teach you something that a lot of students always get confused. Okay? Don't copy first, just listen up. Okay, so okay. Your halogen, fluorine. Now this one, right, the name is fluorine, chlorine, bromine, iodine. This is when it's an element. Why must it have two atoms together? Because it has how many valence electron? 7. Okay, so fluorine, chlorine, bromine, iodine. Okay, now the first question they will ask you is, what is its natural state? Natural state at room temperature pressure when it's naturally occurring. Okay, naturally occurring. Now, when it's naturally occurring, it's not something we use because fluorine is gas, chlorine is gas. Who's going to give you all these dangerous gas to play with? So in our school lab, we don't use it when it's in natural state. But they will ask you, when it's in natural state, how does it look like? That means chlorine without anything, without add water. So I'm going to show you. Okay. Fluorine looks like this. Okay? Can? This is gas, Gas, Okay. Okay, like this, Now, chlorine looks like that. Almost the same, right? Fluorine and chlorine, the gas looks almost the same. Okay? Bromine, is it a gas or a liquid? Liquid,
But it releases gas, I think.
Yeah, but at room temperature pressure, it's a liquid. It only
Okay.
becomes, okay. And then iodine. Okay, what's the color? Don't look at this one. This one is in water. This one pure. Gray, black, gray, right? Grayish black. Correct or not? Okay, can see or not? Okay, this is when it's in its natural state. Okay? They very rarely, so fluorine, right? They don't really ask you, so you don't need to remember. Don't worry about fluorine. They won't ask you this. Okay? Natural state, this is a yellow-green gas or greenish-yellow gas. Can you see here? Okay, pale yellow-green gas. It's a gas, Bromine is a red-brown liquid. Red-brown liquid. Okay, and iodine is a gray-black solid. Now, this is before I add anything. So, can you see how it changes? Gas, liquid, solid. Is it becoming lighter or darker? So, if they ask you astatine, you must say black solid. Lower than that also, black solid. Get it or not? Okay? Make sense? Okay, do you understand? Can Okay, but we
Okay.
don't use it. We don't use it in its natural state because it's dangerous. So in the school lab, we put it in water. We add it into water. So in water, it's called chlorine water, bromine water, iodine solution. But when you write the chemical equation, it's still Cl2, Br2, I2. You still write it like that. But the name is called chlorine water. But some students think chlorine water, they go and make their own formula. Cl2H2O add together. And who teach you like that? Bromine is called bromine water. It's called bromine water, but when you write the equation, it's still Br2. Iodine is called iodine solution. When do you use iodine solution? To test for? To test for presence of?
Touch.
Thank you, start. Yeah. Mm. So, this is orange and this is brown. Last time we called bromine brown. Why they put orange and brown? It's actually to differentiate that this one is lighter, this one is darker. Get it? Mm.
Can't they just put brown and dark brown?
This one not my invention, so don't ask me, okay? Ijo
Okay.
asking why can't put brown and dark brown. It's not right. So this one, don't worry, they won't ask you the color, but basically it's also pale yellow lah. Can understand? Get it? This one and this one they always ask. Fluorine very reactive, 没有人给你玩的, so don't need to remember. Okay, got, but nobody is going to let you play, so don't have to worry. Now, when it's a halide ion solution or salt. Okay, what do I mean by halide? Halide means it's an ion or it's a molecule. This is a halogen. So halide is what? Halide is fluoride, chloride, bromide, iodide. It's called halide. Okay? So when it forms a solution, it forms like when it's ion, negative ion, halide. So halide is ion. Halogen is molecule. So when does it form an ion? So for example, sodium chloride, potassium chloride, potassium bromide, potassium iodide, sodium iodide, sodium chloride. Get it? Lithium chloride. All of these guys are what color? Ding, ding, ding. They're all soluble in water, right? What color do they form? Solid is white. Solution is color. Understand or not? Don't confuse this. Okay? So all of this one, all of this is white solid but colorless solution. Colorless solution. Get it? Okay. Now this one we just learned that day. When precipitate. What is precipitate? Soluble or insoluble? Insoluble. For example, what chloride is insoluble? I'll give you billion points. Come on. You can memorize. Insoluble.
Yellow. Yellow is silver.
Silver chloride,
Silver chloride.
Pb chloride,
PV.
Lead chloride. So, silver chloride, lead chloride. Silver bromide, lead bromide. Silver iodide, lead iodide. What is the color? This one is white precipitate. This one is cream precipitate. This one is yellow precipitate. Remember or not? Don't confuse this. Okay, I give you a few minutes to absorb and copy. Absorb into your soul. Okay? Please absorb and copy now. We will discuss soon. Now, I want you all to imagine. Okay. This is your dad, your mom, your dad, your mom, your sister or brother, and you. Okay? Dad, father, mother. Mother's name is Claire. Okay? Brother and I. Okay? All of you are playing basketball. The concept of basketball is to catch the ball or don't catch the ball. Catch the ball. Who's going to catch it first? Father. When father catches the ball, is fluoride still fluoride? No, now it is fluoride. Okay? Can? Chlorine, bromine, iodine, say, gimme, 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 please. Can or cannot? Cannot. No one is going to let them take it. Okay? So, now fluoride has the ball. Ha, ha, ha. Okay. Somehow, bromine got the ball. When bromine got the ball, now it's bromide. Right? Chlorine and iodine both say, I want, I want, I want, I want, I want. Who is it going to give to? Chlorine. Chlorine. So it's like, okay, take, 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 take. So chlorine will become chloride. Yay! And bromide will change back to bromine. This is called displacement. Wait, I'll explain. Okay, a more reactive halogen can displace a less reactive halogen from halide solution. Okay, write this down. This is called displacement. Okay, I'm going to write equations. You don't need to draw the fundamental. I'm just showing you an example. Just write the meaning of displacement. I want to show you equation. Okay? Okay, ready? Okay.
Okay.
Rồi bà Huy Hoạt đặt tên. Okay. So like this, huh? We're talking about this equation, this reaction, So this is sodium bromide solution. And I add chlorine water. Okay, step one. All I want you to do is draw this and write the formula of chlorine water and sodium bromide. That's it, just the formula. Okay, we start with that first. No, no, just the formula. Okay, so chlorine water is Cl2. If you write Cl2H2O, I will go to your house and hunt you down. Okay? What is sodium bromide? NaBr. If you write NaBr2, I will also go to your house and hunt you down. Chlorine is a molecule. NaBr is Na plus and Br negative. Right? Right? Who is holding the electron now?
Yeah.
Who wants the electron? Cl2. Can Cl2 take it? Yes. So don't write first, listen. So Cl2 says, I want the electron. Give me now. So when it takes the electron, it becomes chloride. Correct? What does Br negative say? Take. Please take. Don't hurt me. You are more powerful than me. Take. Okay, look at the first equation. This is a half equation, right? What kind of reaction is this? Reduction or oxidation?
Reduction.
Thank you. Very good. Reduction is gain electron. Oxidation is lose electron. This two is called half equation. Ionic equation is when I just show the two equations together. This is called ionic equation. Okay, you write this down now. And then chemical equation is when you write everything. It's sodium, right? So who displays who? Chlorine displaces bromine. Yeah, chemical equation.
最下面那个是chemical
Chemical equation, yeah. Okay, ready? Now, I want to ask you a very important question. Where is your eye? Your eye is looking at the dropper or your eye is looking at the test tube?
Test tube.
Test tube. What is the color of the test tube? What's like you? Think. Not nothing. What's the color? Colorless, because sodium bromide is colorless. After the reaction, what color does it change to? What color does it change to?
yellow.
It's already the color orange. Because it's not in natural state, what it's in water, what? So colorless to orange. Get it?
Yeah.
Okay. Did you understand?
Yeah.
Okay, listen carefully. Write down chemical equation, ionic equation, half equation, observation, and if there's no change, write no change. Don't invent your own color change, okay? All right, let's do this. Let's finish this, then we can all go home. So this one,
Yes.
bromine plus 2 electron become bromide.
Yeah.
Do you get it correct?
Yeah.
From colorless to
Wow.
brown. This one, look.
这个不用写。
Wait,还没有写。This one no change.
如果在那个读阶级的时候，我的思考啊，这些东西你想到买哪些？你过就是跟就是
No, they won't ask you to write one. They will say if there's no reaction, write no reaction. Check carefully, colorless to
Brown.
brown.
Yeah, that's just fine.
Okay, Ken? Okay. The last part of this chapter is group 8. Okay? What does group 8 do? Nothing. Because it has a full outer shell. It is used for industrial users only. So, for example, it is unreactive, monatomic, and has a full outer shell. That's it. That's all you need to know. Okay? Basically, it does nothing. Get it or not? Okay?
需要考虑的问题。
Okay.
They said no, they will ask you why is it unreactive. Then you say it's unreactive because
Group
it
8.
is because group 8 has a full outer shell. What is the name? It is known as what do you call it?
Noble gas.
Noble gas. Okay. Alright, that's
Bye bye.
all. Okay, you can go enjoy your bio already, okay? I see you next
Okay.
week. Bye bye.
Bye bye.
Bye, see you.